Good evening, students. I'm your physics teacher Vikal, and today we are going to discuss about thermodynamics, state, variables, and equation of state. So we have already discussed in the starting of the thermodynamics about thermodynamics state variables. State variables already we have discussed about. So now we will see what is state variable. State variable. So to define the equilibrium state, to define the equilibrium state, we want some variables. To define the equilibrium state, we want some macroscopic variables. And those macroscopic variables by which we define the equilibrium state of any system are called as state variables. Okay. अब हम लोग समझते हैं कि होता क्या है state variables. Now we'll understand. Okay. A system of gas is given, and that gas is at equilibrium. Now, how will you define this gas is at equilibrium? If this gas is at equilibrium, that means it will have some fixed quantities, we can say, fixed variables. Like it will have some fixed pressure, it will have some fixed volume, it will have some fixed temperature, it will have some fixed mass. Okay, so pressure, volume, temperature, mass. If the system is at equilibrium, then we can define a fixed pressure, we can define a fixed volume, we can define a fixed temperature. Okay, so P, V, T, M, these all variables are known as state variables. State variables. Now, if we will heat this gas, we will heat this gas to temperature T dash, then its pressure will change, temperature will change. So state is defined, we can say state variable is defined as those particular variables which define the equilibrium state of any system. Okay, now I will give you one example. If I have a box, or we can say I have a container. So one wall is there in this container, which divides this container into two halves. Okay, in one half, some gas is filled. And this half is empty, or we can say here it is vacuum. Okay, so some vacuum is there in other half. Now, if suddenly we remove this, in this time, like at this instant, this gas will have some fixed pressure, some fixed volume, some fixed temperature. If suddenly we will remove this wall, then what will happen? If we will remove this wall, these gaseous particles will start to fill this vacuum. So when these gas particles are filling this vacuum, we can't define any particular pressure, we can't define any particular temperature, and we can't define any particular volume of the gas. When these gas particles will start to fill this vacuum, we can't define it, pressure, volume, temperature, because system is not in equilibrium, not at equilibrium. System is in transition state. ट्रांजिशन स्टेट मतलब बदल रहा है, बहुत कुछ उसमें चेंज हो रहा है. Now eventually after some time what will happen, this gas will completely fill this container and it will be at equilibrium condition. So now we can define its pressure, pressure of gas, volume of gas, and temperature of gas. And that can be P dash, V dash, T dash. Okay. Like that, we can define state variables when system is at equilibrium. But if system is not at equilibrium, we can't define. We can't say some pressure will be there, because here here pressure will be different. Here pressure will be different for this. Here temperature will be different. Here temperature will be different. Here volume, like we can't define state variables. State variables can only be defined at equilibrium, or vice versa. We can say, to define equilibrium state, we want state variables. Simple. Understood? What is state variable? ठीक है? चलो. Now, state variables are of two types. First is intensive, and second is extensive. Intensive and extensive. So intensive means, intensive state variables are those state variables which are independent of mass. Independent of mass. And extensive are dependent on mass. ठीक है? So ये हमको कैसे याद रखना है? Intensive independent of mass, extensive dependent on mass. अब समझते हैं इंडिपेंडेंट और डिपेंडेंट कैसे होते हैं मास पे. Now we will take a gaseous system which have some wait a minute. Here some gas is filled, and this gas is at equilibrium. So it will have some pressure, some volume, some temperature, some mass, some density, some internal energy. These are state variables. So it will have some pressure, some volume, some temperature, some mass, some density, some internal energy. Now what we will do? We will just divide this container of gas or the system into two halves. Into two halves we have divided. Now see what properties will change. Those are dependent on mass. What properties in these properties, in these variables, what variables will change, those are dependent on mass, we can say. And the properties, the variables which are not changed, those are independent of mass. So simply we can say density will not change. Density will not change. Density will remain same. So density is intensive property. Density is intensive property. Mass will change. Mass will become half. Here half gas is there, in other half gas is there. So mass is dependent on mass. Simply we can say. Volume is changing. Here you can say when there was no division, at that time volume was V. But when we have divided in two halves, volume changed. Here V by 2, here V by 2. So volume is extensive property, extensive state variable. Okay. Now pressure will not change. Pressure will not change. If you are in a room and that room is divided into two halves, so in both rooms pressure will not change. So pressure is independent of mass, or we can say intensive variable. Temperature will also not change. Temperature, it doesn't change. If you are in a room, you just divide that room into two halves. In both halves, temperature will be same. Okay, so temperature is intensive property. Similarly, like internal energy will change. Internal energy will change. It is dependent on mass. Internal energy is what? Internal energy is kinetic energy, sum of kinetic energy of molecules. So molecules will become half. Internal energy will change. Simple. Okay, so these are independent of mass. So these are intensive properties or intensive state variable, and these are dependent on mass. So these are extensive state variable. I hope all of you understood. What is the difference between intensive and extensive properties, or intensive state variables and extensive state variable? Okay. Now, last topic is equation of state. Equation of state. So the equation which relates or connects state variables of a system is called as equation of system. Equation of state is called as equation of state. Okay. So like we have for ideal gas, we have ideal gas equation. Okay, and that is what PV equals to mu RT. PV equals to mu RT. So we know pressure is state variable, volume is state variable, R is constant, temperature is state variable. Okay, and this equation relates all the state variables of a system. So we can say this is an equation of state. This is a equation of state for ideal gas. For real gases, in chemistry we study that for real gases the one other equation is there. Okay, but in physics only ideal gas equation is there. We have to study about only ideal gases. Okay, so for real gases, equation of state will be different. For ideal gases, this is the equation of state that we study in physics. Okay, so this was just equation of state. That's it. Okay. Now we will do a problem on equation of state. It was asked in 2020. Simple question, very simple question. What is given? Let's see. A cylinder contains hydrogen gas at pressure of 249 kilopascal. Okay. Temperature 27 degrees Celsius. Okay. Its density is, they're asking density of the gas. R is given, universal gas constant 8.3. Now we know equation of state. For ideal gas is PV equals to mu RT. PV equals to mu RT. Okay. So PV equals to mu RT. Mu is what? Number of moles. How can we write? PV equals to number of moles we can write as mass of the gas divided by molar mass of the gas into RT. Okay. They are asking density, and density का formula हम लोग जानते हैं. Density is equals to mass upon volume. So here in this formula, in this equation, we have to take mass divided by volume. How can we make m by v? Just volume transfer this side, and this molar mass transfers this side, shift this side. Okay, so we will get P into molar mass equals to mass by volume. That means density rho RT. Okay, हमको पता क्या करना है? Rho. So rho equal to what? Rho equals to pressure into molar mass divided by RT. So pressure is given. P equals to 249 kilopascal. That means 10 to the power 3 Pascal. Temperature is given 27 degrees Celsius. But here we have to put temperature in SI unit. SI unit means Kelvin. So 27 degrees Celsius को Kelvin कैसे change करेंगे? 27 plus 273, and that is what? 300 Kelvin. Okay. And what is molar mass? Molar mass of hydrogen is 2. So 2 into 10 power minus 3 kilogram. So molar mass will be 2 into 10 to the power minus 3. So put all the values. Pressure is 249 into 10 to the power 3. Molar mass is 2 into 10 to the power minus 3. R is given 8.3. And temperature is 300 Kelvin. If you will solve this, all the calculation, then you will get 0.2 kilogram per meter cube, and option B is correct. Okay, so I hope you understood. Simple question. Just we have to use this equation, ideal gas equation, PV equal to mu RT. And here we have to make this formula of density by dividing mass by volume. Okay, simple. So I hope all of you understood these topics. Specific heat capacity, state variables, and equation of state. So for today that's it. कल फिर मिलेंगे हम लोग किसी नए टॉपिक के साथ, थर्मोडायनामिक्स का ही. ओके, सो इफ यू आर न्यू हियर, subscribe the channel, like the video, and share with your friends. Thank you.